North American Math Connect Go. Today we are going to move on to the second chapter of IB, which is function and function composition. So let's first define what a function means. Function is defined for every single value of x value. There is one and only one value for the range, which is y value. Recall that in the later part, if we talk about range, we mean just give me a sec. Yeah, range, it means y value. Domain, it means x value. So for example, if we have two dots, then they form a line. 1, 3, 2, 4, it is a function, while 1, 3, 1, negative 3 is not a function. It may seem a bit confusing, but I'm going to give you multiple examples to help you see that. So this is the first example. Do you think that it is a function? I'm going to give you 20 seconds. Okay, so basically you can find that it is not a function, even though it seems like it is x squared plus y squared is equal to 25, but as you can see for 0, there's 2 points here. One is here, and the other is here. So therefore, it is not qualified to be a function. Now let's look at the second one. Do you think that this is a function? I will again give you 10 seconds. As you can see, it is a function because for every x value, there is one and only one y value. So this is a function. Now let's look at this one. Is this a function? I'm going to give you 20 seconds. Yes. So basically, this is a function because, as you can see, for every value there is only one single value. Yeah. So okay. So as you can see, after we have talked about those, let's then move on to the arithmetic combination of function. So we know that function, it can be added, subtracted, minus, and divided. So for example, if we use this one as an example, fx and gx, it can be summed up. So in this case, fx is going to be added with gx, which is going to be 3x plus 2 plus x squared minus 3, which is equal to this, x squared plus 3x minus 2. It can also be subtracted, i.e. one function subtracts another. In this case, it is going to be the first one subtract the second one, 3x plus 2 minus x squared minus 4. So it will be negative x squared plus 3x plus 6. The second example is going to be the multiplication. So it's fx times gx, which is going to be, you time those two functions together. So it's 3x plus 2 times x squared minus 4. So, which is like, it will be equal to something. The fourth one is equal to fx divided by gx, which is equal to 3x plus 2 divided by x squared minus 4. So, this means that, however, remember that for division, gx, the denominator function, cannot be 0 because we all know that a division cannot be divided by 0. So this means that gx, it can only be 0, okay? So x squared minus 4, this means that x is equal to plus or minus 2. Okay. Now let's talk about the notion of them. So the sum has the notion of f plus gx divided by fx plus gx. The second one is equal to f minus gx is equal to fx minus gx. The second one is equal to f times gx, which is shown like this, is fx times gx. The third one is equal to f minus gx divided by gx is equal to fx divided by gx. Now let's try another example. Okay, so try this. We know that we given that fx is equal to 2x plus 1 and gx is equal to 3x plus 5. So we are required to find the four of the followings. The first one. Because f plus gx is equal to fx plus gx, and we know that fx is 2x plus 1 and gx is 3x plus 5. So we can make 2x plus 1 plus 3x plus 5, so it's 5x plus 6. The second one is equal to fx minus gx. So it's equal to 2x plus 1 minus 3x plus 5. So it's equal to negative x minus 5 minus 4. Third example, f g fx. So it is equal to this, right? Because the multiplication symbol shows that fgx is equal to fx times gx. So it is equal to 2x plus 1 times 2 to the power of 3x plus 5, which I'm not going to factor it out completely because it's too complex. The third one. However, for the third one, we need to remember that gx cannot be equal to 0 because the denominator cannot be equal to 0, okay? That's not equal to 0. So we know that gx cannot be 0. So we need to find out the value of x such that gx is equal to 0, and then we eliminate it. So for example, we know that x is equal to negative 503. This value is bad. We cannot use it because if we use the value of x equal to negative 503 divided by 5, it will be equal to 0. The denominator will be equal to 0. So this can be transformed into x is equal to negative 5 divided by 3. That's not equal. Here we come to the end of our lesson, and I hope you have enjoyed a lot. See you next week. Bye bye.